No, I got like, yeah, not really. I got some stuff, but
Okay, f is positive integers from positive integers to positive integers, right?
yeah.
Here we have a complicated term. Can you tell me that complicated term is what?
F of fx squared.
This part. And I told you when we have a complicated term, try to do what? Try to get rid of complicated term. And here we should focus on this part. How we can get rid of this complicated term?
Try and find some substitution.
You should write two equations. One equation is the main equation. You should write another equation to be able to cancel complicated term.
So I can write something like, if I set x equal to 1, I get f of 2y equals 2f
Oh,
of
no,
f of 1 plus 1.
no, not like that. No. Let me. This complicated term is only related to x, right?
Well, yeah.
So for example, if you change y to z, then 2z f of x squared. Let me minimize it. Plus x is equal to f of x plus 1, f of 2xz. Right? Okay,
Yeah.
now use these two equations to get rid of the complicated term.
So now I have y over z equals f2xy over f2xz.
If you divide, what about the case that, for example, one of them equals 0?
But it's from positive integers to positive
Exactly,
integers, right?
exactly. Because they are positive, we can divide. So y over z is equal to f of 2xy over f of 2xz, right?
Yeah.
Okay, now it is so much useful. Use this and try to find f is what?
I guess, can you say like fx equals just x?
But it is not guessing, you should prove. Could you
I mean,
prove
I
any
don't know.
good result?
No.
So f of 2xy times z is equal to y times f of 2xz.
Yeah.
So, for example, if y is equal to z is equal, no, this one not used. If x is equal to z is equal to what? Then we can conclude what?
Then f of 2y equals y f of 2.
Yes, we can consider f of 2 is a constant. See? So we proved that f of even numbers are equal to yc. Okay? So first result was this, second result was this. So we found f of even numbers. Now try to see can you find f of odd numbers, okay?
Okay, so I got f2b plus 1, where b is just some positive integer, equals b times c plus 1.
Can you say it again?
I got f2b plus 1, where b is just an positive integer,
Uh-huh.
equals b times c plus 1.
Exactly. B should be positive integer, right?
Yeah.
Yes, that's correct. And you proved this, right?
Mm-hmm.
Okay. So let's first simplify this. Here it is f of x plus 1 times xyc. So we can cancel y from both sides. And xc here we have. So 2f of x squared plus x is equal to f of x plus 1 times xc. Now, f of x squared plus x. So let me close this. Okay, so here, if we consider x has 2y, for example, then 2f of 4y squared plus 2y is equal to f of 2y plus 1 times yc. F of 4y squared is what?
F of 4y squared is f is 2y squared times f of 2. Two y squared times c. Hello?
F of it is 2y squared c, right?
Yeah.
Okay, f of this part is what?
F of this part is y squared c plus y
Yes,
multiplied by c.
exactly. Is equal to f of 2y plus 1 times yc, right?
Yeah.
We can cancel c from both sides. And f of 2y plus 1 is equal to 2 times yc plus 1, right?
Mm-hmm.
But here, what's the problem? Why here we have 2? Here when we replace x
No,
with
it's
2y, it
4.
would be 2y,
2
right?
2c. Yeah.
Yeah, so we can also cancel these 2's. So we can cancel these 2, and it would be yc plus 1, right?
Yeah.
Okay. So we prove that f of, so it is third result, right?
Mm-hmm.
And we know that y is positive integer, means here it is for f of 3, at least f of 3, right?
Mm-hmm.
Now try the rest. We found f of even, f of odd, and now we should find f of odd at least 3. You should see, does it satisfy all odd numbers? What about f of 1? And does it work for all c or for a special c? Okay.
Okay. Actually, if I want to find f of 1, then why can't y be 0? Why does it need to strictly be a positive number?
Why? Because when you replace y 0, then here we need to calculate f of 4y squared. Then you need to calculate f of 0. But we know that f is from positive integers to positive integers, right?
Yeah.
So that's the reason that here it is at least 3. So you should find f of 1 and you should check for what values of c these answers work.
Okay, wait. So the problem statement doesn't say that x and y have to be integers, right?
X and y have to be positive integers.
Hmm. But I can if I plug in y equals 1/2 to the equation, I get f of 1 equals
Y
f of
equals
2 over
1/2, you cannot replace y with 1/2. They should be positive integers.
Okay, well I get f2 equals c, f3 is c plus 1, f4 is 2c, f5 is 2c plus 1, f6 is 3c, and so on like that.
Yes, but you should check these and you should see if for all values of c, does it work or not? And also you should find f of 1. Okay, we know f of 2 is what, f of 3. Yes, these are the things that we reach. What about next step?
Well, I'm not sure what to do.
As a hint, here we replace x with an even number. For the next step, try to replace x with an odd number. Okay.
Okay, well, I got c equals 2.
Okay, you prove c is equal to 2. And could you find
Yeah.
f of 1 or not?
I didn't try to find f of 1 yet.
Okay.
I don't know how to prove f of 1 is equal to what.
Okay, one hint.
Yeah.
Okay, so when we replace x with 2y plus 1, let me. Okay, minimize. Here again, we know we can cancel 2y, or let's say here y. We can cancel f of y, f of 2, or yc. So f of 2xy, this one. When we cancel 2y, how we can? We said x2y. Okay. So here you can cancel y, and here it is xyc. It is xc, right?
Mm-hmm.
Now we can say, okay, 2f of x squared, which is 4y squared plus 4y plus 1 plus 2y plus 1 is equal to f of 2y plus 2 times 2y plus 1 times c, right? Agreed.
Yeah.
So f of this one is what?
F of 2b or not b 2y squared c plus 2yc plus 1.
It doesn't have, it has plus 1, yc plus. Okay, so
2y plus.
now it is 2f of 2y squared c plus 2yc plus 2y plus 2 is equal to f of 2y plus 2 is what?
It is just c times y plus 1.
Yes, c times y plus 1 times 2y plus 1 times c, or c squared, right? F of this one is what?
I factored out. Wait. Oh no. Okay. First I did. Turn into just 2 times c times y squared c plus yc plus y plus 1.
Is equal to c squared, y plus 1 to y plus, right?
Yeah, and I cancel out a c first.
You can say yc times y plus 1. So yc plus 1 times y plus 1 times yc y squared c plus yc plus 1, right?
Yeah.
We can cancel y plus 1, we can cancel c, so 2yc plus 1 is equal to c times 2y plus 1, right?
Yeah.
It
C
has
equals 2.
two approaches. Yc is equal to 2.
Because now you have a 2yc on both sides.
Because what?
If you just expand it, you get 2yc on both sides.
Yes, one way, because approach 1 or solution 1 for this part. We say it is correct for infinitely many y, right?
Yeah.
And this is a polynomial in terms of y, a polynomial in terms of y, and the degree is 1, right?
Yeah.
When two polynomials are equal to each other for more than maximum of the degree, here maximum of degree of this one, and this one is 1. For more than two values, then we can say corresponding coefficients are equal. Do you know this point?
No.
So let me tell you, it is important in polynomials, the most basic thing. Suppose p of x is a polynomial, and let me say is a polynomial. For example, we can say p of x, when we write like this, means the integer or real numbers, okay? Suppose degree of p of x is n, okay?
Okay.
Suppose that p of x is equal to 0 has more than n roots. Then what can we conclude? Suppose p of x, for example, when it says the degree is n, a n x n plus a n minus 1 x n minus 1 to a1 x plus a0. If p of x equal to 0 has more than n roots, what can we conclude?
But the degree is already n, but it has more than n roots.
We know when a polynomial has degree n, it has exactly how many roots in complex numbers?
N roots.
N roots. But if it is equal to 0, has more than n roots, for more than n values, it is equal to 0. So what can we conclude?
It equals 0 for all x.
Yes, p of x is 0 for all x, and also we can say coefficients are what?
0.
0. So when we have a polynomial with degree n, for example, degree more than 1, it can't have more than the degree roots, right?
Mm-hmm.
Okay, and another thing. Suppose p of x is equal to q of x. Or let me tell you something. Suppose degree of p of x is n. Degree of p of x is q of x is m. And suppose p of x is equal to q of x has more than maximum of m and n roots. So because degree of p of x is n, so it is a n x n to a0. Q of x is bm x m to a0. Okay.
Okay.
So if it has more than n roots, what can we calculate?
Both of the functions are just 0.
No, they are not functions. They are polynomials. In functions, we don't have these conditions, right?
Well, qx minus px has to be 0. So, the n equals m, and all the coefficients are the same.
They are equal polynomials. Their degrees are equal and all related coefficients are equal. Okay? Means p of x is equal to q of x for all x, and all coefficients m is equal to n, and a n is equal to b n, to a0 is equal to b0. Okay?
Okay.
And can you prove it by previous one? Suppose we have this theorem. Let's call this one theorem 1, and let's call this one theorem 2. Try to prove theorem 2 by using theorem 1.
Okay, so if you do qx minus px, then you obtain a new you get a new polynomial of degree m minus n, or of max m and n.
Yes, degree of max m and n, because maybe the leading coefficients cancel each other out or not, right? Degree of h of x is equal to at most maximum of m and n. Then what?
So if using like what we figured out in theorem 1, if this has more than m n like roots in the complex plane, that means that it has to equal 0 for all x.
Yes, and then they are equal, right?
Yeah.
Yes, good job. Now here, if you consider from that point, it is a polynomial with degree 1 in terms of y, right?
Yeah.
P of y is equal to qy for infinitely many y's, right?
Yes.
And then, so because the degrees are 1, the corresponding coefficients are equal. It is 2c corresponding coefficient of y here, 2c equal. Constant term here is 2, here is c, so c is 2, right?
Yeah.
Solution 2, because it is correct for infinitely many y's, y is positive integer, right?
Mm-hmm.
So you can say, okay, if y is 1, you can say 2 times c plus 1 is equal to c times 2 plus 1. So
Yeah.
2c plus 2 is equal to 3c, right?
Yeah.
So c is equal to 2, right?
Yes.
And f of 2, so f of 2x is equal to xc 2x. X is a positive integer. And also f of 2x plus 1 is again 2x plus 1. Or again x positive integer, right?
Yeah.
Now we should find out f of 1 is what, okay? So again, you know, it is equal for f of x is equal. So, or from these two things, we can conclude f of x is equal to x for x at least 2, okay? And x is a positive integer, right?
Mm-hmm.
And we want to find f of 1, agreed?
Mm-hmm.
Okay, use this point that f of x is equal to x for x at least 2 and try to find f of 1, okay?
Can I see if this works? I don't know if this is correct because I don't know if there's like a correspondence here, but if I say y equals 1 and x and no, sorry. Yeah, okay. So y is no x equals 1 and y is just not y is just y. So it's 2y f of f1 plus 1 equals f of 2 times f of 2y. And then when I plug in I just plug in y equals 1 also.
Yes,
So
you can replace first x, y, 1, okay?
x equals y equals 1.
Yes, and then you can say, okay, it is 2, 2. So you can cancel this one with this one, and it is 2, right? Then what?
Yeah. Well, I don't know if this is correct, but you get f of f1 plus 1 equals f of 2.
Why?
Cool, because 2 is equal to f of 2. Right?
It is equal to f of 2, but if you prove it is a one-to-one function, you can cancel f, right?
Yeah.
But we don't know it's a one-to-one or not, agreed?
Yeah.
Okay,
Well,
you
it
should
is
prove it with another approach, and it's not hard. You said what?
Okay, I'll try.
Okay.
I don't really see how to solve f of 1. Which
Okay, so one thing,
yeah,
do you agree f of 1? F of 1 is at least what?
at least 1.
Yes, f of 1 plus 1 is at least what?
2.
Do you agree we proved f of x is x for x at least 2?
Yes.
And because it is at least 2, we can say f of that is equal to itself, f of 1 plus 1, right?
Yeah.
So it is equal to 2, so f of 1 is 1. Understood?
Yeah.
Okay, so we proved then for all x in positive integer, f of x is x, right? When you reach this one, again check, okay? You should check eventually your last answer, okay? So it would be 2y times x squared plus x. Is it equal to x plus 1 times 2xy? We cancel 2, we cancel y. It is x squared plus x, it is x times x plus 1. They are equal, right?
Yeah, there you go.
Okay. So we proved homework 2. Homework